All right, let's talk about functions. So let's start with this question. All it says is determine whether or not it's a function, right? That's all it says. So here, let's look at A. Is that a function?
Yes.
What's the function called? It's a polynomial. So what is it? It's
Is
x
it
cubed.
quadratic?
No, not quadratic. Quadratic, the end behaviors have to be the same. So it's gonna end up where it started, right?
Mm-hmm.
For quadratics, it's gonna end up where it started, or cortex. That's x cubed. And it says state its domain and range. It's a polynomial function. What's the domain of a polynomial function? So it's XER. What about the range for
It's YER.
its YER? Exactly. Easy peasy. And yes, it is a function. B, is B a function? B is a little bit trickier. It's not as obvious, but is it a function?
It's not.
It's not. All right, let's look at B in more detail. I think it is. Because if you rearrange it for Y, so let's do B. So what I'm going to do is I'm going to rearrange it for Y. So subtract 3x squared on both sides. So negative 3x squared plus 6, and then divide both sides by a 2. You see like that? Is this a function? Negative 3 over 2x squared plus 3. What about this?
It is a function.
It is, it is. It's just a quadratic, right? It's just a quadratic. So what do we know about this function? Is it opening up or down?
Down.
It's opening down, right? And because it doesn't have an x term in it, the b value is 0. There's no x term. Your y-intercept, okay, for quadratics, if there's no b value, the y-intercept is gonna be your vertex automatically. So the sketch of this, you don't have to be precise, would look like this, where that is your y-intercept of 3. So this is definitely a function. What's the domain and what's the range?
The domain is XER.
Yeah, what about the range?
Y has to be less than 3.
Can it be equal to 3?
Yes.
Yes. Y is less than equal to 3. And that's it for that one. So the quadratic is a function. What about C?
It's not.
Okay, why not? What does it fail? It fails something, right? So you know it wasn't because of a reason, and that was because it fails the vertical line test. So a function has to pass the vertical line test. A passes it. Vertical line test means when you draw a perpendicular line straight up and down, it can only touch the curve once, right? If you see it here, it touches it once. But for C, we're going to touch it multiple times. So it fails the vertical line test. So C is not a function, okay? That'll be the reasoning because it fails the vertical line test required for a function. So if something is a function, this is required. If it fails, then it's not a function, it's called a relation. So C is not a function, it's simply a relation. But even for a relation, we can state the domain and the range. What's the domain for C? The possible
It,
x values it can take. So I'm just looking at the graph, right? X values looks like if minimum is -1, maximum is 1. What about the y values?
YER.
YER is right. And that's the answer to that. D is again a little bit complicated because it's not in terms of y. To see a function from an equation, you have to rearrange it in terms of y. I have x equals 2 to the power of y. How do I solve this equation for y? Note that y is in the exponent, so you'd have to use a method that would allow you to bring the exponent down.
You use log.
You use logs. So you get log of x is equals to log of 2 to the power of y. Now this will allow you to bring the y down. So you have log of x equals y times log of 2. So therefore, y is log of x divided by log of 2. And this is equivalent to log base 2 of x. So if you have a numerator-denominator component, the denominator becomes the base in a log thing. So the question is this a function? This is just a log with a base of 2. It'll look something like this. Is log a function?
Yes.
Yes, it is. What's the domain and the range from the graph? I can make it more precise. So log of x is the inverse of an exponential function. Exponential has a horizontal asymptote. Log functions have a vertical asymptote on the y-axis. They always go through the x value of 1, like how parent function of exponentials go through the y value of 1. It's going to come from down there. It'll never cross that asymptote. It's going to cross through this x-intercept, and then it's just like a square root function. So that's the sketch of log base 2. Base 2 doesn't matter. It's always going to go through this. The only difference is that it'll look like this, right? That's the difference. Or it could also come down. So these are all the various bases. But the main idea is that it's always going to go through that point. It's always going to write that asymptote. So knowing this, what's the domain and range of this plot?
The domain is that x has to be greater than 0,
Yes,
and the range is yer.
yes. So that's log base 2 of x. In a log function, if a base is not specified, like here, the base is 10. That's the default. Let's look at this next question. A cell phone company charges a monthly fee of $30 plus 0.02 dollars per minute of call time. Write the monthly cost function, CT, in terms of T, where T is the minutes. So we want CT, right, equals to something, where CT is your monthly bill that has two components. It has the flat amount, right? Remember, flat amount is always going to be the y-intercept, and then it has the slope. And slope always is attached to your variable. So your t will come here. So it'll be something times t. So what's the equation? It's just y equals mx plus b.
It's 0.02t plus 30.
Yes. Part B, find the domain and range of t. So this graph of this would look like this. I mean, it's just a straight line going up, and that's your 30. So now be careful, okay? This is a trick question because it's a real life situation. What is the domain and range of C? You have to take into account the context of the question. Don't only think of it mathematically, think of it practically. C is dollars. If you want C is dollars, right? So your Y is dollars, and on your X you have minutes. What's the domain and what's the range? So X represents
Has to
minutes. Yeah?
be greater than 0.
Yeah, X has to be greater than 0. What about Y?
It also has to be greater than 0.
No. When is Y gonna be 0? For what minute is Y gonna be 0?
30.
Uh, so Y is not, so you're not, you flipped it there. So the question was, for which X value, right? For which X value is Y going to be 0? Because you said the range was this. So now think about this. For which X value is the Y value 0? It's some negative number here. You see, this is where the Y value is 0. Can the Y be 0? No. Why? Because Y is dollars. Can dollar amount be negative? No. So Y is greater than 0 is not the right range. The range should be Y is greater than 30. Do you understand why? It's for the same reason as this. Why is X greater than 0 and not XER? It's because minute has to start from 0. Why is Y greater than 30? Because the minimum monthly bill has to be 30, right? Anything less than 30, you'll have negative time, which can't happen. So that's why the range is Y is greater than 30. Cool?
Yeah,
Again, not that difficult. What type of function do we have here?
absolute value.
Absolute value. What's A? What's K? What's D? What's C? For an absolute value function, this is it. So compare this with that. What's your AKDC?
A is 2.
Yes. K is the number multiplied with X.
K is 1.
K is 1. Yes. What about D? D is -3. And C is -1. Yeah? So it says graph this. K as 1 does nothing, so we can ignore this. So the absolute value function looks like this. Goes through 1, 1, -1, 1, 2, 2, -2, 2, right? Looks like this.
Mm-hmm.
So the first thing we're going to do, A is 2, it's a vertical stretch. All the X values, they stay the same. The Y values, they double. So look at this. It becomes 1, 2. I can draw it right here. So look at this. All the Y values, they're going to double. The X values are the same, but all the Y values here have doubled, okay? So that's what A is equals to 2 does. X values stay same, Y value doubles. What about D is equals to -3? Does it move it left or right?
Is it left?
It's left. So this curve, we're just going to move it 3 units to the left, so it'll look like this. And now that point is -3. What about the -1? What does that do? This -1 here.
You move down?
You move down. So for the final answer, this is your graph. And this is your minimum value, your vertex essentially, and that is at -3 and -1. So that'll be the sketch. So now let's talk about the domain and the range. I mean, if you have the points in a curve, it's very simple. What's the domain and range of this curve from the sketch?
Domain is XER.
Yes. What about the range?
Y has to be greater than or equal to -1.
Perfect. In terms of properties, absolute value function is equivalent to x squared. If you look at absolute value, it looks like this. X squared looks like this. It's just the straight line version of quadratic. They both have a vertex. They're both increasing and decreasing. They both follow the same pattern for the AKDC. The only difference is that x squared is curved, whereas the absolute value function is straight lines. We may or may not have done something like this last time. It says, describe this interval using an absolute value notation. So what that means is it's asking you to do, there's going to be a absolute value of x. There's going to be some operator here, usually an inequality. And then over here, you will have, so this is for the symbol. And then on this side, you will have a constant usually. So now think about this. What's the number that you're interested in? Where does it start and where does it end? 2, right? 2. Now, which symbol in there would describe this notation? Are we less than 2 or more than 2?
Less?
Less than. Can we be equals to?
No.
No. So this is it. That's the answer. You're done. It's just that symbol. It's always going to be the absolute value of x. When it asks you to denote it using absolute value notation, you'll always have this component. You'll have an operator. You'll have a constant. Identify the intervals of increase and decrease, the symmetry, and the domain and range. All right, how hard could it possibly be? Let's begin. 3x looks like this, some points 1, 3. Where is it increasing? Where is it decreasing? Is it decreasing anywhere?
No.
No. Where is it increasing? Everywhere, right? It's increasing everywhere.
Mm-hmm.
XCR. Where is it decreasing? Nowhere. The symmetry. Symmetry just means, is it an odd function? Is it an even function? What is y equals x? Is that an odd function, even function, or neither? So there's two types, right? It's either odd or even. Odd, even, neither. You remember these guys? Odd is when you have it's x. This is odd. When you are doing a reflection about the origin. So odd functions look like this, right? Look like this. When you flip them around the origin, okay?
Mm-hmm.
Even, on the other hand, I mean, it's x squared. You know what an even function is, like this, or like a sine x. So these are even function. Neither means it's neither, obviously. So x is going to be an odd function. 3x, the 3 doesn't make much of a difference. It's just a vertical stretch. The graph is still symmetrical. Let's look at b. And the domain and range for a straight line is XCR. That's super simple. Let's look at b. So x squared plus 2, it's opening up, and we know the y value is 2. So this is the sketch. What's the interval of increase? Where is this function increasing? if anywhere. It is increasing somewhere.
When x is greater than 0.
Yeah. So to the right of 0, it's increasing. To the left of 0, it's decreasing. What about the symmetry? Odd, even, neither.
Odd.
Odd, so just remember what it means, right? Odd, again, is a reflection about the origin, whereas an even function is a reflection on the y-axis.
Even.
Even. Domain and range, XER, y greater than 2. Let's look at the last one. What type of function do we have for C?
Exponential.
Exponential. Graphically, it looks like this. Goes through a y value of 1. What's the interval of increase?
It's always increasing.
Yes. So that means it's decreasing nowhere. Symmetry, odd, even, neither. So you ask yourself, right? If it was a reflection on the origin, okay, it's always going to be on the other side of the map. What I mean by that is if you have a chunk here, you're putting a mirror here, right? That means you are going to get something here. Same thing with this. If it was a reflection on the origin, because you already have this blob, you should be getting another blob down here. But we don't have this, so it's definitely not odd. Okay? Now the question is it even? Does this look like it's a reflection on the y-axis? So if you put a mirror here and you close your eyes, what you have here, do you have the same thing here? No, right?
Mm-hmm.
So what's the symmetry? Odd, even, neither. 3 options.
It's neither.
Yes. D, it says domain. What's the domain of an exponential function? It's the same as a polynomial, XER.
XER.
What's the range of an exponential function? Oh, it's -1, sorry, it's -1. So that means, what that means is that the asymptote will actually be now at -1 instead of being at the origin, like that. All the y values go down by 1 because of the -1. That means this is going to go through 0, 0. So the range is going to be y is greater than -1, exclusive, not inclusive. Exponential functions, the c value, this is the c value. C is always going to be the horizontal asymptote in an exponential function. Let's look at this one. State the parent function and the transformations, and then it's asking us to graph the transform function. All right. A, you don't need anything. What are you expecting that graph to look like for A? What's the transformation that happened?
It moves to the left by 1.
Correct. So you know what an absolute value function looks like. It looks like a V, right?
Mm-hmm.
The parent function goes through origin like this. So A, the curve, will simply look like this, and it'll go through -1. Very, very simple. Let's look at B. What's the parent function? For B, what's the parent function?
It's a radical function.
It is a root function, okay? Square root function.
Mm-hmm.
I guess it is a radical function, but a root, you can be explicit with it because it's root 2. So what do we know here? A, K, D, C. What do we know? What's given? Any of these given for part B?
Is -7.
D is indeed -7. What's K?
It's 3.
What's A?
-0.25.
Yes. What's C?
0.
0. So here's the thing. If you have a question like A, where you only have one transformation, you can kind of do it by hand. But if you have multiple transformations, if you do it by hand, you're gonna have to make multiple sketches precisely. I think a better approach when there's multiple things happening is the point mapping rule, which says xy on the parent function, which is square root. So 0, 0, 1, 1, 4, 2, 9, 3. The points on the parent function become x over k plus d, a, y plus c. So here it's going to become x over 3 minus 7 and negative 0.25y. You agree? So let's plug these in. I'm going to do these first. This is a 0, negative 0.25, negative 0.5, negative 0.75. So those are my y values. For my x values, I divide by 3 minus 7. 1 over 3 is 0.33 minus negative 6.66. Cool. And then for the final step, we're just going to plot these guys. Negative 7, 0. Negative 6, 6, this. Again, you just need the general pattern. I'm not going to be precise here. That, negative 0.5, so negative 0.66. Okay, yeah, it makes sense, makes sense. So it looks something like this. Cool?
Mm-hmm.
Is it difficult?
No.
All you need for transformation is this. If you have this, there's no question that they can give you where you won't be able to solve it. All right, let's look at this one. So now it's stating the transformation in words, and we have to kind of change them into mathematical symbols. Is horizontally stretched by a factor of 2. Now think about it. Horizontally stretched. Is k gonna be 1 over 2 or is k gonna be 2? For k,
1
it's the opposite. Yes, good. K is gonna be 1 over 2. And shifted 3 units down. What have they given us? What does that mean? Shifted 3 units down.
C.
C. C is minus 3. Find the equation. All right, now look at the equation. K always has to be inside the function. Your function is x squared. K is always the number multiplied with the x, right? X minus d, you
Mm-hmm.
can say x minus 0 if you want, or you can just say x. And squared, c value and a value are outside the function. Our function is squared, so the minus 3 has to be outside. Okay, like that. And that's our equation. You can open this bracket if you want. This becomes 1 over 4x squared minus 3. So again, it's a look something like this.
But what about like the reflection in the x-axis? Does that like change anything?
I completely missed that. Yes, it does. So that means A is -1. So yes, it does. So there's a minus sign outside here, okay? Outside the squared, so that's not going to become positive. When you open this, the minus sign will still be here, like that, okay?
Mm-hmm.
So instead of opening up, it's going to open down.
Okay.
It'll look like this then. Cool? That's it. Okay, we're done with this. Let's look into inverses. They've given us a bunch of points and function notation points, and we're asked to find the inverse relation. What's the inverse of 1, 2? Remember, from a coordinate perspective, you're just flipping it. I'll do the first one. It's 2, 1. X becomes Y, Y becomes X, right? Look at this, how easy this is. What about the next one?
-9, -1.
I'm not gonna bother with C. Let's work on D, E, F. So now we want the inverse relation. This gives us, so you have your function f. When you input 5, you get output 7. This is our flowchart right now. We've been asked to inverse it. That means instead of starting here and ending there, we have to start there and end here. It's a little bit tricky if you don't know. So the way you want to do this is I'll do the first one. It's going to make so much sense if I just give you the answer to the first one. So the inverse of f5 equals 7 is f inverse of 7 is 5. That's it. So what that means is if you plug the value of 7 into the inverse function, you'll get an output of 5, right? It's the exact opposite. You see this? What are we trying to do? We're trying to input 7 in f inverse so that we get output 5. So if they give you fg or something, they're asking you to find the inverse relation. You need to write it in terms of f inverse or g inverse. What's the answer to E? It's very similar to the one that we just did.
You just do g inverse of -3.
Equals 0. Yeah?
Mm-hmm.
What about the next one?
H inverse of 10 equals 1.
Done. So the coordinates, they flip. But when the coordinates flip, they take their domain and ranges with them. Here's what I mean. You have your f, you have your domain, you have your inverse. You have your f inverse. The domain here becomes the range here. The range here becomes the domain here. That's how inverses are related to one another. So I'll do the first one, and then you're gonna do the second. It's very simple. So for A, it says domain is XER. So look at this. So for A, we have domain range. Domain becomes range. So this domain of XER, it's gonna become the range of YER. And this range will become XER. Y becomes X, X becomes Y, right? And then -2, X, 2. There you go. That's the answer. The range, the domain becomes the range, and the range becomes the domain. And obviously, you're going to switch X and Y's accordingly. Domain should always have the X, range should always have the Y. Did that make sense?
Yeah,
What's the answer to B?
the domain is y is no, sorry. The domain is x is less than 12,
Mm-hmm.
and the range is y is greater than or equals to 7.
Easy peasy. Graph each function and its inverse relation on the same set of axes. Let's start with the quadratic one. What's the y-intercept for the quadratic? So not the y-intercept. What's the x-intercept for the quadratic function?
-4.
-4 is the y-intercept. What's the x-intercept for the quadratic function? What are the two zeros, if there are any? No?
2.
2, plus minus 2, in fact. If you're confused about this, right, here's how you solve it. Again, this is quadratic. X squared is going to be 4. X is going to be the square root. Whenever you take a square root at this level, you're going to plus minus 2. So your two x-intercepts are plus 2, minus 2. So a rough sketch would look something like this. Now this is f of x, right? Note the points that we used for f of x. We used -2, 0, 2, 0, and 0, minus 4. This is for the parent function. What are some of the points on the inverse function? Do we know any points on the inverse?
0, -2,
0, negative
and
2.
0, 2.
Yes. 0, 2. So let me use a different color. 0, 2 up here. 0, -2 down here. 0, -4. Sorry, -4, 0, right? -4, 0. And then you connect the dots. And that's the inverse function. Did that make sense?
Mm-hmm.
It's very simple. You just use the points from the parent function, and then you do a little bit of a flippity flip. Is the inverse function a function? Is f inverse a function? Think about the vertical line test thing.
It's not.
It's not a function. In fact, I don't know if I told you this, you don't have to draw it to see it. Let's say the question's asking us, is the inverse of this a function? Well, we know what that looks like roughly. So for the inverse to be a function, okay? For the inverse to be a function, it needs to pass the horizontal line test. Notice how the horizontal line crosses it twice, right? So it
Mm-hmm.
fails the horizontal line test. Therefore, the inverse of a quadratic of this will not be a function. So you can look at it that way as well, okay?
Mm-hmm.
So let's do B. B is a little bit annoying, but again, we can come up with some point. Can you give me a couple of points for B? What are some points on the curve of 2 power x? You agree with this? I just plugged x and y. So let's graph that. So -1 and 0.5, 0 and 1, 1 and 2. And again, it's going to come here. It's going to go forever. And again, remember, for an exponential function, the -0 or the +0, you have a horizontal asymptote here. So that's the parent function. What are some of the points on the inverse function?
0.5, -1, and then 1, 0, and 2, 1.
So it ended up looking something like this. Again, remember, it's a reflection, so it should be a mirror image. around the origin. So the origin is this line.
Mhm.
Is the inverse a function?
Yes.
Yes. What's the name of the function for the inverse? It has a name. We did this today. We talked about it. What is the inverse function called?
Um,
It's log x, okay? Log x. Remember, the inverse of exponential is logarithms. So this is log base 2 of x, and this is 2 power x. They are inverses. Find the inverse of each of the function. So to do it algebraically, you have to follow a few steps. So this is doing it algebraically. One, you're gonna swap x and y. X becomes y becomes x. Swap is a dumb word. What's the technical word for this? I'll give you the technical word. It's called interchanging the variables. I'm still gonna call it swap, but that's what it's called, interchanging the variables. X becomes y becomes x. And then you wanna solve for the new y. When I mean solve, I'm talking about isolating it. And then this new y is technically your f inverse. So let's do A. So this is your y, this is your x. That x becomes y, that y becomes x. How do we solve this for y?
you subtract 1 and divide by 2.
Yes, so therefore f inverse of x. Okay, remember this, the new y is f inverse of x. So f inverse of x equals x minus 1 over 2. Final answer done. Easy peasy. Let's do B. Why don't you help me with B? What's the first thing we do?
You take the, you,
It says right there, step number 1. Swap x and y, right? Y becomes an x becomes a y. How do we solve this equation for y?
take the cube root.
Do you have to do plus minus when we're doing the cube root? Or is that strictly for even indices?
It's only for even.
It's only for even. You don't have to do the plus minus for odd index. So therefore, remember, this is your f inverse. F inverse of, sorry, g inverse now. G inverse of x is equals to the cube root of x. And that's the inverse. Very simple, just takes 2 steps. Let's look into piecewise functions for a little bit. If you're given an equation that has multiple parts, you see how this one has 2 parts. The top function is valid to the left of 1, the bottom function is valid to the right of 1. This is called a piece. How do you spell piecewise? Piecewise, yeah. Piecewise function is the name for this. Because it has multiple pieces, multiple parts. Graph the following function and determine whether it's discontinuous. So a discontinuous function is something, it's only 2 things. It's either gonna be an asymptote or it's gonna be a whole. If either one of these exists, then it's gonna be a discontinuous function. Actually, no, sorry, there's another one. Or like jumps. Three conditions for it to be discontinuous. You know what a hole means. Hole is just like a hole in the curve. Asymptote is an invisible barrier. But what is a jump? A jump is something like this. Let's say you have a curve that's valid to 1 right? Like that. And then from 1, you have another curve that's valid like this. Notice how we jumped from here to here. There's no link. Jump just means you're not connecting them using a curve. So that's called a jump, and that's going to be a jump discontinuity. Okay?
Mm-hmm.
So let's graph this and let's see whether or not there is a discontinuity. So again, it's not that difficult to graph. It's just two straight lines. If you look at the equation, you have two linear functions. How hard could this possibly be? So step number 1, identify the x value of interest. So the x value of interest is a 1. This number. So to the left of 1, the function that's valid is 2x. What does 2x look like? Like this. 1, 2, right? 0, 0. You know what 2x looks like.
Mm-hmm.
So it goes through the origin, and slope is 2. But this function is only valid to the left of 1. And is 1 inclusive? No, it's not, right? It's exclusive. That's why I'm denoting that by an open circle. And therefore, my first piecewise function, I'm just going to connect these dots, will look something like that. Something like that. There you go. So that's 2x. Cool?
Mm-hmm.
For x plus 1, what's the y value at this point? For the next function, what's the y value when the x value is 1? What's the starting point? Basically, what I'm asking you is what's the starting point? So for this one, plug 1 in there, right?
It's 2.
It's 2. So when the x value is 1, the y value is 2. We already had a 2 there from the first circle, but that first circle was an open circle. This y value of 2 is now going to be a closed circle. And what happens is that this is going to close the hole from the first guy. What's the next point? When the x value is 2, the y value is 3. So that's just a point, and therefore the other half of the equation will look like this. And this goes on forever in both directions. Is this continuous or no?
It's continuous.
Yes, it is, because there's no gaps. Let's look at this next one. Write the algebraic representation for the following piecewise notation. So we're going to write something like this. So it's the opposite. So it's going to be in this format. So let's see. F of x is going to be equals to curly bracket, two conditions, because we have two curves, right? Two curves means you're going to have two equations here, two conditions. What's the x value of interest? Where do the two curves kind of meet?
2.
2. So both of these is going to be, if x is going to be less than 1, less than equal to 1 for the first one, less than equal to because it's going left, less than, equal to because of that closed circle. Yeah? What about the next one? What's the bound for the next one? If x is what?
Greater than
Greater,
2.
greater than 2. Not 1, 2. All right, so now the last thing we need is the two linear equations, right? Let's look at the first curve. The y-intercept is -1. Remember, y equals mx plus b. Y-intercept is -1. What's the slope of the first curve? You can count it. You have a sketch. Do you want me to draw a triangle? I think this might be helpful. What's the rise? So count the boxes.
3.
1, 2, 3. What's the run?
2.
2. So therefore, the slope is 3 over 2. So therefore, the equation is 3 over 2x minus 1. Yeah?
Mm-hmm.
Why don't you struggle for the next 30 seconds? Come up with an equation for the next curve and tell me what it is. I'll help you. You know what? I'll help you. I'll give you a hint, and the hint is that I'll give you the y-intercept. The y-intercept is a 0. Tell me the equation for the second curve. The y-intercept is 0. All you have to do is find the slope. Draw a triangle. You want me to draw a triangle? I can do it. I won't count the boxes, though. You're going to do that. Tell me the slope of the second curve.
It's -1/2.
Perfect. Is this piecewise function continuous? You're just looking at the graph. Is the piecewise function continuous? No, right? Remember what continuous means? It's one smooth motion. If you have to lift your finger, that's discontinuous.
Mhm.
From here to here, there's a jump. This is called jump discontinuity, okay? So it's not continuous. A continuous function should be one smooth motion. But if there's a hole, then obviously that's also not continuous. Let's do one last question for the day. I'm going to sketch this. You're going to answer the question. And once you have the sketch, it's actually very simple. So again, what's our x value of interest? Where do the curves kind of separate? 1, yeah? X value of 1 is going to be our point of interest. So I'm going to start with the first curve. I know that x squared plus 1 looks like this. It has the y-intercept of 1, and then it goes up. So when the x value is 1, what's the y value for the first function?
It's 2.
Open circle or close circle?
Open.
Open. And then we know it's going to come down to the y-intercept of 1. So it's going to come here, and then it's going to curve back up, right?
Mhm.
Cool? So
Yeah.
that's the first part. What's the y value for the second equation? When the x value is 1, what's the y value for the second equation?
It's 3.
It's 3. Open circle, close circle.
Close.
Close, right? So 3 is right here. Let's close this circle. Um, Now we need another point. So when the y value is 2, sorry, when the x value is 2, the y value is going to be 6. So 3, 4, 5, 6 right here. And I'm just going to connect these dots. And that is our second function. Why don't you answer the question now? Is it continuous at x equals 1? Why or why not? Let's go. Let's hear it.
It's not,
Why not?
because you have to make a jump.
Yeah, so this is a jump discontinuity. It is not continuous. That's the entire answer, right? Again, not that difficult. Always start at the x value of interest. Sometimes you'll have multiple x values. You'll see this another time. There's no class tomorrow. I'll see you next week.
Okay.